Wonderful.
Hey, that was
All right, so great. Yes. See some more people coming in. I'm sure we'll have more join as we get started, but to give our speaker as much time for her talk, let's get started. Hi, everyone. Thanks for joining us for the second part of the 2025 ISAR Virtuaeolian Seminar Series. The entire board is really excited to continue this Virtuaeolian tradition with Pavla today. Before we get started on today's talk, I just want to go over a quick structure of today's webinar. Please keep your microphones off until the end session, Q&A session. At that point, please feel free to unmute to ask a question. Please feel free to type questions in the chat at any time. We will wait till the end to read them out loud, but feel free to queue up questions as the talk is going. During the Q&A, please just raise your hand if you would prefer to speak out loud, just so that we can keep it orderly here. This meeting is being recorded, if you didn't hear already, and we will be sharing it with the ISAR community on our website and our YouTube page. You can see our previous talks there, so we encourage you to go check out the website. Please also hang with us until the very end, because we have some announcements to share. And lastly, we just ask that everyone contribute to creating and maintaining a welcoming and respectful working environment that fosters diversity, inclusion, and belonging. And so now I'm going to turn it over to Philippe to introduce our speaker. Thank you.
Thank you, and thank you, Pavla Dagsson-Waldhauserová, to have accepted this invitation to give this talk for ISAR. We are very happy to have you here. So just a few words to introduce you. So you are assistant professor and researcher at the Agricultural University of Iceland, and also at the Czech University of Life Sciences in Prague. And importantly, you are the leading the Icelandic Aerosol Dust Association, which I don't know exactly what organizes programs, dust monitoring, dust measurements at the European scale in the polar region, and your research focuses on polar air pollution, and particularly on dust storms and dust cryosphere interactions, and this includes field work in polar region, both on both poles, both in Arctic and Antarctica, as far as I understand. And we are very glad to have you here, because this connects what we are more used to, that is dust in tropical desert regions, whereas your dust is away from the tropics. So please. This is the screen is yours.
Thank you very much. It's a great pleasure to be here with you today, either morning or noon or afternoon or evening. And and thank you for the introduction. It was very nice. And I will probably start directly sharing my slides and then just go through everything I want to show you today. So just a second. Yes, so now you should see the first slide, which is actually showing the upcoming three presentation of the ISAR Virtuaeolian series. So I am the first one today, and I will talk about the high latitude dust. Just a second. So here is the intro slide, and you can see what I'm showing here. It's actually based on a huge cooperation of my colleagues from many countries, and also the results I'm going to show are based on several funding teams and projects that some of them have been already concluded, some of them are just starting. So once again, welcome, and I will talk about the atmospheric observation from the volcanic deserts and glacial environments at high latitudes. As the introduction slide, I actually chose winter modest satellite image from south coast of Iceland, where you can nicely see the dust plumes exceeding 100 kilometers from the south coast over the ocean. And this is just to show you that although the satellite is actually exactly cut it at the edge of Iceland, which is about 62 degrees north at this point, but you can still see that the dust occurs all year round, at least for the South Iceland. So at the beginning of this talk, and now finally you can see, I actually thought the best would be to start with the key facts we know about high latitude dust. So I chose these 7, and that is that high latitude dust actually is to contribute to the Arctic amplification through the dust albedo feedback. High latitude dust was also recognized as an important climate driver in polar regions in the IPCC SROCC report in 2019 and again in 2021 in AMAP report, which stands for Arctic Monitoring Assessment Program. Important fact is that the dust hotspots in the Arctic are often located in ice proximal areas with frequent floods bringing fine sediments from beneath the glaciers. High latitude dust storms that we measured cause severe air pollution, and it often happens that the recommended health limits are 1,000 times higher than it should be. For example, in Iceland, we have 135 dust days reported annually, and it has been shown that the dust can travel thousands of kilometers inside the Arctic, but also more than 3,000 kilometers towards the Europe, and I will show you some examples of it. And 2 most important points are that the high latitude dust has impacts on atmosphere, cryosphere, marine and terrestrial environments, and it causes severe erosion and land degradation. And it has also impacts on socio-economic sectors in terms of health, road safety, energy production, aviation, land degradation, and more. And here I have chosen some pictures for what we've experienced in Iceland in past 3 years. So after the severe storms in November, you can see the dirty windows. Icelanders really like their warm swimming pool outside, but after dust storms, it sometimes happens that the pools are full of sand in the bottom of the pool. Then often it happens that there are damaged cars after dust storms without windows, and the visibility on the roads is really quickly impaired and you don't see anything. And then also 10% of Iceland are actually glaciers, and many of them actually suffers the interaction with the dust, so they are actually really dirty. And on the top you can see we also have a snow dust storm, so which looks actually as a dune. It's a dirty snow with dust over it. So this was for the beginning, so you know what the talk will be about. And the outline is that first I will show the high latitude dust sources. Then I will take the advantage just to quickly show you the existing high latitude dust networks. And then I will proceed to the in situ observation of dust, mainly atmospheric, in Iceland, Antarctica and Svalbard, and show 1 slide on the high latitude available dust forecast. Then there will be a few slides on the long-range transport of high latitude dust in the Arctic, but also of a low latitude dust traveling towards the Arctic. And this is from the sources in Sahara, Middle East, and also Aral-Caspian areas. And then hopefully time allows, and I can show you some major impacts, climate impacts of high latitude dust, and also socio-economic impacts. And because we are here having people that really enjoys the aeolian processes, which also involves dunes. So I thought of showing some pictures of volcanic sand or dust dunes. And at the end, I have the slide with conclusion and the outlook. So let's start with the high latitude dust sources. The first paper was published in 2016, which summarized the important areas where the high latitude dust sources are in both hemispheres. And then lately in 2022, there has been update on this paper where more than 60 new high latitude dust sources were identified, and it's summarized in the paper of Outi Meinander from 2022. But to conclude, these sources are both in northern and southern hemisphere, and for the northern hemisphere it's in Alaska, Canada, Greenland, Iceland, Svalbard, Siberia, and also Scandinavia. And for the southern hemisphere, the most active sources are located in Patagonia, Antarctica, and New Zealand. Very helpful tool for identifying the dust belt and where are the most important desert areas located that emit dust has been opened and done by Anna Vukovic. It's called Sand and Dust Storm Source-Based Map, and you can freely access it. And originally it was done through the United Nations Convention to combat desertification, to identify the low latitude dust sources and their intensity, and also basically to show where the dust belt is. But then we actually asked them to, why have you excluded the high latitudes? And adding the same information from the high latitudes, there has been the northern dust belt identified. And this so-called SDS, Sand and Dust Storm Index, shows the intensity of the dust storm occurrence. But this is, of course, variable during the year and also during parts of the year. So some years are high dust active and some years are a little bit maybe lower dust active. And for your area of interest, no matter if you study the high latitudes, Arctic or low latitudes, you can use this tool actually to see the sand and dust storm index for different parts of year. So I chose this example for Svalbard, for example. You can see the differences between spring, summer, and autumn. And the same can be found for other areas. I will just summarize the big paper, which has over 50 papers on the newly identified climatically and environmentally significant high latitude dust sources, which had over 50 co-authors. So the first part is focusing on identifying these active sources, which in the active dust year actually exceed 1,600,000 square kilometers. And the estimates are saying that high latitude dust actually contributes about 1 to 5% to the global dust budget, according to different studies. And the second part of this really huge paper actually is a summary on high latitude dust climate impacts through cryosphere, direct impacts through ocean fertilization, and, for example, through the ice nucleation of the clouds. There are also many sources in the north. Eurasia, for example, here are marked with the yellow dots, and these are the dust observation from the meteorologists through the form of the synoptic codes. And unfortunately, we don't have much information neither from in situ measurements, observation of or satellites from these areas. And one example is this Shoyona village in Kanin Peninsula in Russia, where people can basically only get in the summer season with the helicopter, and you can see they indeed are living in the middle of the dunes. Now about the high latitude dust networks. So there is important contribution from the World Meteorological Organization, which is hosting the Sand and Dust Storm Warning Advisory and Assessment System. And World Meteorological Organization itself is one of 19 members of the United Nations Coalition Combating Sand and Dust Storms, so-called UN Sand and Dust Storm Coalition. And this World Meteorological Organization, SDS WOS Center, has 3 different nodes. One is in America, Pan America, one is in Asia, and the third one is together for Northern Africa, Middle East, and Europe. And we are very proud to say that Iceland is actually part of this NAME mode, the North Africa, Middle East, European node. And it's also due to the size which consider the active deserts, and that makes Iceland actually the largest desert Europe outside the west part of the Caspian Sea area, which actually still is geographically part of Europe. So the high latitude dust networks which are active today is the mentioned IceDust Association. Then it's the Arctic thematic network on high latitude dust. Now we are also proud that there is this CAMS National Collaboration Program for Iceland, which focuses mainly dust. That stands for Copernicus Atmospheric Monitoring Service. And last year there was also regional, let's say, Nordic network on researching dust, and that was called NordDust. For the IceDust Association at the moment, there are 57 research member institutions from 22 countries. In number, it's more than 110 members. There have been more than 60 scientific papers published, and we are also very proud that the association was accepted to European Aerosol Assembly in 2022, aside the other important European aerosol associations. And we organize this high latitude dust workshop every February, and actually next year we will have the 10th anniversary, so everybody welcome to join. And here are the member association of the European Aerosol Assembly, and they are actually two Nordic at the moment, so it's the IceDust Association and also Nordic Society for Aerosol Research, NOSA. You can visit and find more information about the IceDust Association on our website, and I would again emphasize you can contribute, but also just to follow us during the high latitude dust workshop, and also on Facebook there is a group Dust Storms in Iceland, and we also organize a session at the EGU which is focusing the atmosphere cryosphere interaction. So that's where you can meet us as well. The second network is the Arctic thematic network on high latitude dust. That has been very successful. It's also a platform where we engage more students and organize different schools. And basically, it's a great tool to report our activities. And one of few networks, actually, our network has been selected for the success story. So you can see more on this link if you are interested. And the NordDust, as I mentioned, so the main outcomes, there is a high latitude dust assessment, which is still in progress. We also applied the EU coast action on high latitude dust that at the end wasn't successful. And there was a high latitude dust mini review led by Outi Meinander again, focusing dust in the Arctic and the impacts on climate, but also ecosystems. And it was nice during this year of this NordDust. We had actually this amazing event when you can see the Icelandic dust indeed was reaching Scandinavia, and you could see it on even in the true color on the MODIS. And another great success is that Iceland is now included in the United Nations Sand and Dust Storm Toolbox. There are 6 important sections, as you can see on the left, and you can find us in 2 or 3 of them, but it's a generally really useful tool for any type of investigation or mapping of desert areas, and especially those that are impacted by dust storms. So that was the overview about the networks, and now I will proceed to the in-situ observation and the high latitude dust forecast. We will start with Iceland. So that's where I conduct most of my research. And as you can see, 40% of Iceland is actually area with severe up to severe erosion. And there are also these green dots, and that's areas which is defined as dust hotspots, and these are so-called hyperactive areas which produce the dust in basically almost daily daily variability, and it's basically through the interaction with the glacier where the very fine sediment is released, and that's very easy to suspend. And the other map is the map of the current working stations of the Environmental and Energy Agency of Iceland, providing air quality information. But as you can see, most of them are not located around the desert. So based on that, Iceland is actually declared as one of the cleanest air country in the world. But the reason why is basically the lack of the measurements. Also, all of these stations are not even measuring particulates, so it's also for volcanic gases and other air pollutants, but not the particulates. So looking at Iceland and the sources of air pollution, I already mentioned it. So the total Icelandic extent of desert areas in Iceland is 44,000 square kilometers. And what makes Icelandic dust so active is that it's also area of very frequent strong winds. Then is the glacial activity, which I already mentioned through these glacial floods. And I avoided to use them outburst waves here because they are still defined as a sudden events. But when I talk here about the glacial floods, they indeed occur daily for maybe 1 or 2 months, and that's the new source of material, and I will show you how it looks like on the next slide. And the third reason is the volcanic activity. Although we have these frequent eruptions, on average 3 to 4, one eruption occurs every 3 to 4 years, but that has been probably now accelerated with the Reykjanes Peninsula eruptions, but not all of them are explosive, having volcanic ash in it. So the latest one are mostly effusive without much of ash in it. And the other important source through the volcanic and geothermal activity are these waves, which are the glacial outburst floods caused by warm, either subglacial eruption or some warm geothermal activity. And this has been reviewed in this paper from Arnalds and Altri 2016. You can find it there. So here is the example of flooding in the desert that occurred in 2021 on daily basis, and now again this August 2025 when I was there. And you can see just during one flood like this, when we had the international field campaign with really expensive instrumentation and many research group joining, you can see just during this one flood you can have up to 25 centimeters of new material, because the last layer is always ending with the brighter color because the fine particles settle at the end. So again, these glaciers are the most important sources, plus it's of volcanic origin because that's the Icelandic parent material. So we don't have much dust observation, and everything started with the pioneer dust observations and the sporadic field campaigns. 3 of them I want to emphasize here is the extreme wind erosion event of Eyjafjallajökull ash and together mixed with the dust. It was in year 2010 after the eruption was declared as ending. Then snow dust storm. So the middle picture indeed shows a dirty snow after a basically the snow dust storm. And then we also observed these really particular dust events on the floodplain, which occurred during high precipitation season, and there were no winds. So the only driving mechanism of these plumes and later dust storms was the solar radiation heating the dark surfaces of these floodplains. So here quickly about the extreme wind erosion event of Eyjafjallajökull volcanic ash. So it seems to be on Earth, this has been one of the most extreme wind erosion event recorded, because using these BSNE dust traps on the right, we measured the aeolian transport over 1 meter transect was about 11 tons per meter, and this storm actually lasted for more than 23 hours and occurred in this marked area on the picture. And also we measured with Sensit, where there were more than 6,000 pulses per minute, and the wind speeds were exceeding actually the hurricane wind speed. So it was a really extreme event, declaring clearly that that the eruption itself, which of course influenced the actions all around the world, but still the events that are occurring after the eruption itself are sometimes of worse impacts than the eruption itself. So, and also it shows that the volcanic ash, fresh volcanic ash, is usually very quickly removed after the eruption in terms of several months. And it again shows that the main sources producing particulates in Iceland are the deserts, not the eruptions. Here are some pictures from the snow dust storm. Again, really dirty snow, and even 300 kilometers from the source, you can see dirty cars and snow in Reykjavik. The concentrations were really high at the place, about 50 kilometers from the place there was the instrument at the time, so that measured over 6,000 micrograms per cubic meter for 1 minute mean, but over 24 hours, the means were about 1,000 micrograms per cubic meter. And also the composition and some pictures of the particulates shows that mostly 75% of the material is the pure volcanic glass, and there is also quite a high percentage of iron-containing substances, and also organic matter and diatoms. And you can see the pipe vesicular structures of the glasses. Then finally came the year 2023, and we established the first long-term monitoring network of deserts of Iceland. That was through the CAMS project. As you can see, the location, one is in the northeast, one is in the south, and one is in the southwest in Landeasandur Desert. And here are some first year results. So, for example, for the South Station in Mýrdalsjökull, the annual average for PM10 was 9.8 micrograms per cubic meter, which is more than, actually almost double to triple what is usually recorded for this or announced for Iceland as a background station. But we also had some extreme case studies where the concentration actually exceeded 50,000 micrograms per cubic meter. Then the Northeast Station, Medrudalur, we unfortunately had some failures there, but we have most of the summer season captured up to November. You can also see the clear dust peaks in there. And the station in Landeasandur did not last long, and I show you why later. And we also observed some extreme events over there. Now we are very happy that we can provide the first long-term data set from these stations, and the network has been re-established now again in 2025, so we hopefully will have 3 more years of monitoring. And this is basically mainly for the modelers and people that need to actually verify their predictions of dust. So the main outcome showing the long-term PM10 and PM2.5 annual mean shows that the PM10 from this background station is comparable to the industrial and urban stations in Reykjavik, and the PM2.5 are obviously 2 to 3 times higher than those captured elsewhere in Iceland. And another outcome of this project that there is now new web applications where you can see both in situ measurements, but also the CAMS layers for dust and PM observations. We will also add the Dream Dust operational model for Iceland. And you can also see the road cameras where clearly there are some dust plume visible. And Icelandic Road Administration Service also has a special actually sign for dust storms. So when the road is closed, you can see that the cause is dust storm. So you can see more on this website. And we don't only measure on the surface, we also conducted vertical profilings of dust storms and during the winter. That was in 2016. So during the same day, we were actually lucky to measure the most cleanest air condition, where there was the particle number concentration for PM10 lower than 5 particles, while during the flights which were affected by the visible dust plume on the picture, we had up to 200 or over 250 particles per cubic centimeters, and that's exactly the same what was measured in the dirty Saharan layer with the same instrument, light aerosol optical counter. And we also measured the dust in the polar vortex condition, so we found the signatures of the dust up to 6 kilometers, and it was due to circulating of the dust in these areas, because normally the plumes are not as high in Iceland. And there was a continuation of this now with drone, which actually flew up to 2 kilometers. It was the UK-Iceland cooperation, and we also had a winning science journalist with us, Daniela De Lorenzo, who wrote about this campaign, and you can find it on Euronews. Now let's move to Svalbard. I don't have much experience from there, but in 2024 we organized one of the polar winter schools there. It was organized through the Arctic thematic network I mentioned, and also North Snow network. And as soon as we came to Longyearbyen, that we clearly saw very dirty piles of stone, similar to what we know from Iceland as the snow dust storms. And I installed my instrument in Longyearbyen for about 4 days, and the outcomes were quite surprising, that it's really polluted industrial town. It's not only because of the dust, but also because of the coal dust from the local coal mines and frequent trucks transporting the dust. And also a lot of like high usage, for example, of snowmobiles. On average, there are 3 snowmobiles per 1 person. So very polluted, and surprising information from there. Here are some images from the dirty snow around the mines and the layering in it, and basically comparison to the dunes after, or I mean the snow dune, if I can even define it like that, after the snow dust storms in Iceland. So now there are these events, evidence at least from 2 places. And Antarctica, we have measured in James Ross Peninsula, which is in the Antarctic Peninsula. You can see it on the map on the upper left corner since 2018, but so far we only published the data from the first year. And we can declare, after having these observations, which are only conducted in Antarctic summer, which means winter in the northern hemisphere, that this is the most dust active or dust productive source in Antarctica, even more than the famous McMurdo valleys and elsewhere. And now I show you why. So this is from the paper published in 2018. These are the hourly mass PM10 and PM2.5 mass concentrations, which in terms sometimes actually exceeded the 40-50 micrograms per cubic meter, but that was rather calm here until there was this extremely hot and dry summer of 2021, and these concentrations, and please watch for the logarithmic scale, actually exceeded much higher concentration than in 2018, which already on average was a much higher concentration than, for example, remote stations in North Europe, in Norway or Finland. But yeah, 2021 was much worse, and the inlet for PM10 actually got stuck, so we had to use the previous year to recalculate it, and actually got the average of 45 micrograms per cubic meter, and that's similar to the most polluted EU cities like Madrid, Barcelona or London. And here are the averages from 2018 to 23 for PM1 to PM10. The year 2021 is actually really significant. For PM2.5, this season has on average actually exceeded the World Health Organization health limits. But for PM1, it's also quite high mean. And then 2024 was also quite, it's not in the table, but just added separately here, quite active year as well, although we had only 14 days of measurements. and also the absorbing properties of or the optical properties of the particles there shows very similar to what we see in Iceland, that they are quite absorbing. That means the red or orange colors. Sorry, and that probably is the same for other important high latitude dust areas like Alaska, for example, or basically the volcanic origin areas. And here are the available dust forecasts for high latitude dust, and I am aware I have last 10 minutes. So at the moment there is one operational forecast for dust for Iceland, which has been implemented into the WMOSDS forecasting center. We are very proud of it. And then there is also SILA model from Finnish Meteorological Institute, which nicely provides real-time information for dust sources in both northern and southern hemisphere, including Antarctica. Now I have few slides about the long-range transport. So generally for the Arctic, there has been paper published showing that the most dust which is in Arctic comes from Asia, then from Africa, and about 1/3 is the local high latitude dust sources. And you can see on the bottom how far the dust from Greenland, Iceland, or North America, 60 degrees north, has impacts. But so far, again, the Eurasian north 60 degree sources have probably huge impacts, but nobody really sees it on satellites, or there are no measurements of it. There are studies on long-range transport of Icelandic dust. The first one was from Iceland to Ireland. Actually, the MAZ station had totally different focus on measuring the sulfates, but indeed they received the Icelandic dust storm, so that was already published in 2009. And since then there are two papers showing evidence that Icelandic dust arrived to Svalbard, and there is another paper showing that Icelandic dust has been observed during 2 years of measurements and collected all the way in Balkan Peninsula in Serbia. And generally on all high latitude dust traveling capabilities, there is this paper on the right top from Stefano Cronchianti, and you can find the other dust traveling to Svalbard, not only Icelandic, but also from other high latitude dust areas. In Iceland, we also receive about 1 to 2 Saharan dust events on average based on this study. And what is important, these are the really large particles that travel to Iceland. It's actually up to 100 micron large quartz grain, and we can recognize it because we don't have quartz in Iceland. So this is another nice study showing that. But last year we had many more Saharan dust events than 2. I remember at least 4 we measured. And this is one example showing middle November, and all of a sudden North Iceland experiences temperatures of 26, 27 degrees Celsius. And that also came with large doses of Saharan dust. So there was only one station in Northeast Iceland. It was ours, which was measuring. And we, as you can see, measured some peaks over 100 micrograms per cubic meter for this event. And the best place to measure actually or observe low latitude dust in the Arctic is Finland. So in this study, and that's a reanalysis of MERA2, that in Finland they not only get a lot of Saharan dust events, but they also identify quite a lot of Aralin Caspian area dust events, and also from Middle East. So now to the major climate impacts. I will make this shortly. It's based on the studies I was taking part. So for the Icelandic dust, which is really powerful ice nucleating particle, especially in the temperatures above -17. That's much more active than the low latitude dust. And what happens, it has impacts on the mixed phase clouds. And what happens that it actually changes the supercooled water in the cloud into the ice, and then it changes the albedo of the cloud into darker color. And here were some model estimations. If you also include Icelandic dust to the ice nucleation activity, that it totally changes the forecast for the Arctic area. So why is the Icelandic dust having such a different impacts and important impacts on climate? So you can see it for the on the composition. 75 up to 90% of the different Icelandic dust samples are of volcanic glass compared to African or Asian dust, which are consisting of totally different materials. And this has huge impacts also that it contains high amounts of iron, and that actually turns the Icelandic sources in a very high iron solubility compared to the African sources. And because the North Atlantic Ocean is quite limited, it can have quite important impacts on primary productivity and nitrogen fixation in terms leading in additional carbon uptake. There is also one study on the direct impacts of Icelandic dust compared to the African sources. Icelandic dust are marked here with the red dots. And the most important message of this study is that actually in the near infrared wavelength, the Icelandic dust has 2 to 8 times higher absorption capabilities than African or Asian dust. And all comes from the color. So it's of volcanic origin, it's really dark. And this is a study of my student Taru, which actually made some laboratory experiments showing very low albedo of the Icelandic volcanic dust, down to 0.03 to 0.06, depending on the particle size. The smaller the particle size is, the higher the albedo is. But everything changes when it comes to the wetness or moist, because then the albedo goes almost to the really 0.00, which is the darkest black. And that's actually the implication for the contact of the dust with the cryosphere. And this is nicely depicted here. So here are the shapes of Icelandic glaciers from the year 2000 and their anomalies in albedo. So after the eruptions in 2010 and 11, the glaciers were really covered with quite significant layer of dark volcanic ash. But what happened in 2019 is only impact of the dust storms, because there wasn't any eruption covering the glaciers. And then came year 2022, you can see satellite picture of this massive storm, which actually broke a lens of my camera monitoring the dust storms. And this is the cycle. So adding to the images from before, also the year 2022, the dark areas, this is causing the floods. And then you have the cycle of more dust coming to the glacier and really accelerating melting. And this has been already studied during the field experiments in Lapland, where we compared soot and dust and silt and different materials. And it again actually confirmed that the Icelandic dust has very similar impacts of the cryosphere as black carbon. And we also monitor melting glaciers. So I'm in part of the Planet Watch by NLabs, and here is the location of the camera watching the outlet of Ketluekut Glacier. And indeed, just during the first year, the melting is so rapid in terms of 100 meters a year in horizontal, but also in vertical changes, then that it's in terms of tens of meters. We also documented collapse of this ice cave in Ketluekut, and this is very popular touristic area. So we also see the impacts on the tourism when the glacier is quickly retreating. And that brings me to the other impacts of the high latitude dust, as we know from Iceland, is mainly on the road safety, impaired visibility, or even the speed of the sand and dust storms itself breaks the windows of the cars. This is happening every year, and on average, based on the police reports, there are 2 to 3 accidents caused by sandstorm reported, but unfortunately not always the police actually put the information it was occurring during the sandstorm, and there is also 1 or 2 cases of mortality due to this. And there are also clear impacts on health. And there are some medical studies showing the 2.3 increase emergency hospital visits due to ash or dust, but this is all located and focused on Reykjavik, which is quite issue because there is not enough people to have in the study. It's very limited, so very difficult to compare the PM data from Reykjavik with the admissions. It has to be compared with exposure and dust elsewhere, not only in Reykjavik. So I'm ending. So here are the promised pictures of the volcanic sand dunes from Iceland. This is from Landeyjassandur in the south. That's one of the few, actually the only one hotspot in Iceland which is not at the terminating glacier. And I installed my instrument there in October 2023 as part of the CAMS project, but it was buried already in December 2023. So I've learned that it's not good to locate the instrument right in this sandy or like volcanic dune areas and sandy deserts. And here is the conclusion. So the impacts of the high latitude dust, as we know from Iceland, are on human health, safety, and it has massive impacts of erosion and ecosystem destruction. High latitude dust has been identified generally as important driver of climate change in polar region. Volcanic dust is optically absorbing, and especially in the near infrared. There is the obvious high latitude dust cloud feedback, not only confirmed not only from Iceland, but also Alaska and Canada and Svalbard. And there is also clear high latitude dust albedo feedback, which makes glaciers darker, emphasize the melting, and even shorten the snow coverage area. There is also high latitude dust marine impacts. Through the iron bioavailability and basically increase CO2 uptake. So the recommendations are to raise awareness on high latitude dust, provide more tools to monitor high latitude dust, and especially the in situ monitoring, and include high latitude dust in future climate scenarios. And as my goodbye slide, and I promise I'm ending, is I want to again invite you to join the Facebook group on dust storms in Iceland, where we really provide information on a lot of activities related to high latitude dust. I would like to again invite you to the high latitude dust workshop next February. And what's coming as first, I'm also very happy to be part of science art projects, and one of them is the Dust Forest, which will be open 3rd of October in Paper Arts Museum in London. And on 4th October, we will actually have a science and artist talk in the South Banks Center's members bar. So you are very welcome to join us there. And this is basically dust prints made using the Icelandic dust from the picture behind here, and it's a forest, so you will go through about 200 trunks hanging in the museum like this on special Japanese paper. Thank you very much for your attention.
Thank you.
Thank you, Pavla.
Thank you.
Many applauses coming in through, through Zoom. We already have questions in the chat, which is great. But please feel free to also raise your hand if you would like to ask a question. But I can start by reading the first one from Santiago, unless Santiago, you'd like to unmute.
Yeah,
I wonder. Oh yes, please. Yes.
Oh well, okay, that's okay. Just we are so little. Nice to see so many names I recognize here. Hi, Pavla. Very nice to talk. I was just wondering, is there much dust in Sweden and Norway? I mean, I know there are some glaciers there, but never heard of a report, or satellite images is so difficult to see anything. Do you know?
Yeah, you can see in the paper of Outi Meinander from 2022 the exact location that's been identified, and it's actually both. At least I know places around Lund in South Sweden. It's both from the beaches, but also from the arable fields. And they also have observation of the Saharan dust coming there, so long-range transport as well. And then there are additional places in Denmark, if I'm correct. And so it's not much from the northern parts, although it's really interesting. I'm also aware of the Norwegian fjords are very, very sandy, but never seen any evidence from there. And the paper was based on the evidence. That was really important, that there was a picture behind it, satellite image or in situ observation.
Okay, thank you.
And nice to
Thank
see
you,
you too.
Santiago. We have a question from Alex. Alex, do you want to ask it, or I'm happy to read if
Yeah.
you're not able to unmute?
I'm just on my phone, but yeah, thanks for the talk, Pavla. I was just wondering, in Antarctica, you saw high dust emissions in the summer where it was quite hot. I was just wondering if you knew or had an idea on what processes were driving the increase in emissions. So whether the warm summer was maybe increasing the meltwater and that affects the sediment supply, or if it was drying of surfaces or changing wind patterns, or yeah, I was just wondering if you had an idea on what was actually driving the increase.
Yeah, so, well, generally the Antarctic Peninsula area is one of the most suffering the climate changes, and you can see it really, really in past maybe 30 years. But the summer of 2021 was really specific. Also, the Antarctic Peninsula mountain is usually blocking the wet air masses, so you are really kind of in the shade of these mountains, and the temperature went up to 18 degrees, whereas the averages are usually somewhere between 0 and 8 at that summer. No rain at all, and yeah, it was rather windy. So the supply of the water around the local glaciers in the James Ross Iceland, I wasn't really informed about that they would be melting more. It was a general dryness itself, but I will maybe find out better and can let you know later.
Thank you, Alex,
Yeah,
for the question.
great, thank you.
I have a question also in the chat, but I can ask it. So I was wondering how you can apply this this knowledge to the Martian conditions, where some alien sediments can be also mixed to ice, either CO2 ice or water ice. So it's somehow the Mars is a bit like the poles on Earth. So can you say something? Can you guess something, or do you plan to collaborate also with people working on Martian conditions?
Yeah, actually, when we had this largest international high latitude dust field measurement campaign in Dingusandur in 2021, there were people conducting the studies to actually have it as an analog for Martian environments. For example, Kerstin Szczepanski and even Konrad Kandler and the rest of the group from Spain and also US. And this is so far the best known analog of Mars on Earth, as I have known also the composition. And even before, in 1969, exactly in the same place, there were the Apollo crew astronauts actually training for their mission to the moon. So yeah, and I can confirm by my own experience, it is really feeling that you are not on Earth at all.
You are living on an extraterrestrial place, so to say.
Yeah. And with the cryosphere team, we also do experiments collecting. There is a permafrost as well, and there is also buried snow under the tephra, or this very light pumice of the Askja stratovolcano, buried maybe several tens of years from the last eruption, but from the massive eruption in 1875, and the snow is there. So when we actually met the International Space Station astronauts there in 2021, the question was, where do you find the water on the Mars? And now is the example. So it was about digging under this pumice material, and we found indeed buried snow. Didn't know we were walking on it. So to my knowledge, this is the closest to Mars.
Thank you.
And the in situ measurements hopefully have been implemented in the models that are done for the Martian environment.
Thank you.
Santiago, do you want to go ahead?
We don't hear you. You are muted.
Yes.
Yeah, just a thought. Pavla, I was wondering, have any groups with ocean biology group have approached you to? I mean, now that I see Jan Berend here, wouldn't you consider bringing your boat there and put your buckets and buoys? It's just the perfect place. You have source.
Thank you, Santiago.
I do the satellites.
I was going to ask a similar question, actually. Has anyone looked at the marine response of ecosystems to this dust process?
Yeah, well, with the iron bioavailability, it was the University of Birmingham and Zhongboshe collected some samples and at least presented these papers I was showing as well. And to other marine scientists, I am not really aware of it. Not the Icelanders. That's what I would know.
These are not the best areas to sail in, though.
Yeah.
But I know that they are quite iron limited, so it would be very interesting to see if indeed there is a marine response. And as Santiago suggested, using sediment traps, maybe submarine ones. Yeah.
Okay.
You are very welcome, Jan Berend.
Yes, thank you. Yes. Don't say that too often because I might come back to that. I have another question, if I may.
Well, that could be the transect you have from the west coast of United States towards South America. You could have like transect from Iceland down to Antarctica.
You know how fast these boats go? That will take ages.
Yeah, better to start soon.
Get going.
Yeah, some other question I had, and then I realized that you have two types, right? You have the directly volcanic eruption dust, let's say, and the glacier valley dust. Is that correct?
Yeah,
There's a huge difference in altitude, right, at which they travel.
Yeah, the glacier sources are the most important. I mean, the volcanic eruptions are quite rarely explosive. That's the number one. So, and secondly, the winds are removing the volcanic ash in terms of several months after. So you wouldn't have any ash left because of the windy conditions. So the sources are indeed the glaciers. That's the hotspots with the frequent floods. I was trying to show one image that you can get so much new material on the daily basis, and these floods can occur every day in maybe 2 months period in summer. And at the moment, actually, there was a hollow rain eruption blocking the glacial outwash plain of the northeast Iceland and covered about 30% of the desert of this like hotspot. So people were estimating there will be less emission. But what happened is that the clay started to and silt collected, and the eruption is basically like a dam. So every day you get 2-3 more meters of the new silty materials. And this year, 10 years after it, actually the eruption wall was about maybe 10 meters high or even more. And this year it started to actually go over. So now it's these fine materials are actually spreading all over the sandy desert.
But then at what high altitude does this dust
This
fluid
is
then travel?
700-800. The plane itself is located 700-800 meters above sea level.
Ah, right. Okay, that makes sense. Yeah.
But then next to it is almost 2,000 high stratovolcano of Askia, and you can see it actually flies over it, although it's maybe only 10 kilometers from it.
All right. Excellent. Thanks.
Thank you, Santiago, for sharing that link as well for some high latitude dust activity recently.
Yeah, it's the time of the year for Alaska.
Well, we are at right at the top of the hour. So I'm gonna, if anyone has more questions, please feel free to keep putting them in the chat. We can pass them along to Pavla, or you can reach out to her directly via email. Just a few quick reminders while I still have everyone here. We encourage you to check your ISAR membership. That way you're getting our updates, receiving our quarterly newsletters. If you check the last one, ICAR planning is well underway, and they're actually still starting to collect just interest in who's planning to go. So please check out the link that they've created for the website and share if you're planning to go to ICAR in Namibia 2026. We hope that you'll join us for the next 2 talks that we have coming up the next 2 months. And lastly, and most importantly, we have our ISAR 2026 award cycle open right now. The awards are open for 1 more month, and we have a series of new awards. So we encourage you to check them out. Please nominate your colleagues and reach out if you have any questions. And Pavla's talk will be uploaded to our website soon if you want to watch it again. You can reach us at admin@aeolianresearch.com. If you have any questions, that email's on our website also. So with that, thank you all. Thank you, Pavla, so much. A wonderful talk today. And it was just great seeing everyone. So thank you.
Thank you.
Thank you.
Thanks, Pavla.
Bye.
Bye-bye. Can stop recording now, I suppose.
Yes.
Great. Let me